Hi everyone. In this video, I'm going to give a brief overview of CalAdaptR. In one sentence, CalAdaptR is a package or extension for the statistical programming environment R that provides functions to import climate data from CalAdapt directly into R using the CalAdapt API. CalAdapt, of course, is a website and data portal for downscaled climate data for California, Nevada, and neighboring areas in the Western USA. Most people interact with CalAdapt through the website, but a little-known fact is that CalAdapt also has a well-developed API that allows computer programs to talk to each other so you can get the data directly from the server into R without having to go through the website. With CalAdaptR, you no longer have to download CSV files or TIFFs. Instead, you can get the data you want just for the area you want, directly into R using familiar R functions. If you've never heard of R, it's an open source statistical programming environment that is very popular with data scientists. Some people work with climate data in R in order to make a custom chart, map, or visualization. Or you might be interested in using R for custom analysis, perhaps one that involves combining climate data with other data or models. Or you might want to use R's powerful programming language and Markdown support to create reproducible workflows and share your work with others. The way CalAdaptR works is a two-step process. First, you construct an API request, which you then feed into other functions that fetch data from the CalAdapt server and send you the data either as tables or rasters. Once the climate data are in R, you can then turn to other packages to wrangle, analyze, visualize, and share your work. The first step is to create an API request object. An API request object is a bit like filling in an order form, containing all of the critical pieces of information about the data you want. Every API request needs to specify the location of interest. This could be points or polygons that you provide as coordinates or as R spatial objects. Or it could be one of the dozen or so preset areas of interest that CalAdapt supports, including counties, census tracts, watersheds, and so on. Every API request must also specify the data sets you want. This includes one or more climate variables, such as minimum or maximum daily temperature, precipitation, snow water equivalent, and so on. If you're asking it for modeled climate data, you also have to specify the climate models or GCMs that you want, as well as the emission scenarios. Of course, you have to specify the start and end dates and the temporal aggregation period. The smallest unit of time for the CMIP5 data on CalAdapt is daily. Many of the data sets are also available as annual averages, and a few are available as monthly summaries. If you're querying polygon areas, you also need to specify how you want the data to be spatially aggregated. This is needed in the likely situation where a polygon covers more than one grid cell of climate data. The spatial aggregation option specifies how you want the climate values for those grid cells to be collapsed into a single value for the polygon. Once you've got your API request object in good shape, you're ready to actually fetch some data from the CalAdapt server. There are different fetching functions in the package you can use to fetch data depending on whether you wanted to send you tables or rasters. When that's all said and done, you'll either have tables of data or raster objects. Each row of the table represents one date, one location, and one climate variable. If your API request asks for data from multiple climate models, which is pretty standard practice with climate data, there will be additional columns for the GCM, emission scenario, and so on. Similarly, if you got rasters back, you'll have one raster for each climate variable and model. There are tutorials that come with the package to provide some guidance on how to work with these objects. At this point, you're basically done with CalAdaptR, and you can turn to base R functions and those from other R packages to prepare your data for your next step. R has dozens of well-developed packages for wrangling tabular data working with spatial objects, and handling rasters. For analysis and visualization, you can use some of the excellent packages for plotting, mapping, and doing raster calculations. R also has a number of packages that take climate data as inputs and use those data to model things like growth rates of plants and insects, species distribution, human health impacts, infrastructure load, and so forth. Or you can make your own model. If you can imagine it, there's really quite a lot you can do in R. For more information, the best place to start is the CalAdapt R website, which has getting started guides, all the technical documentation you could ever want, code recipes, workshop recordings, a contact form to ask questions, and more. You can also check out some of my other videos, which include actual code examples and some of the more advanced features. Thanks for watching.